Welcome. In this video, I'm going to show you that the Chebyshev polynomial is a solution to a differential equation. And that differential equation looks as follows: 1 minus x squared y2 prime minus x times y prime plus n squared y equals 0. So Chebyshev polynomials is a solution to this differential equation. To show you that that's the case, let's compute. So each Chebyshev polynomial is a solution to this differential equation. So let's compute t0 of x, t1 of x, and t2 of x. Once we have this, we can show you that each of these is a solution. Okay, first of all, these two are given. This is equal to 1, this is equal to x. So these two are given. Okay, so then we can use the recursive function to compute the other ones, and this can keep going. Okay, so it says that 2x times t1 of x minus t0 of x, that's equal to 2x, t1 is x, minus 1, and that's equal to 2x squared minus 1. So this can keep going like that. For example, t3 of x is going to be equal to 2x times t2 of x minus t1 of x, and this can keep going. So what now we're going to show is that each of these ones is a solution to this differential equation. We're not gonna show the general case, but we're gonna show you that t0, t1, t2 are solutions to this differential equation. So for t0 of x is equal to 1. So we need y double prime, which is the second derivative, and the first derivative. So t prime of 0 of x is equal to 0 because the derivative of 1 is 0. And then of course the double prime is going to be equal to 0 because the derivative of 0 is 0. Now we can plug it into the differential equation. So 1 minus x squared y double prime is 0 minus x times 0 plus 0 squared times 0 times 1 equals 0. And this indeed is the case. 0 times this is 0, 0 times this is 0, and 0 times this is 0. So 0 equals 0, so that's a solution. Now let's compute t1. Let's see if that's a solution. So t1 of x is equal to x, t1 prime of x is equal to 1 because the derivative of x is 1, and t1 double prime of x is 0 because the derivative of 1 is 0. Okay, so now we plug in these things into the differential equation. That's going to be equal to 1 minus x squared times 0 minus x times y prime, which is 1, plus 1 times y, which is x. So that's equal to negative x plus x, which is equal to 0. So that checks out because 0 equals 0. Okay. Let's compute T2. T2 of x is equal to 2, as we from before. T2 of x is equal to 2x squared minus 1. That means that T2 prime is equal to, derivative of this is going to be equal to 4x, and then T2 double prime of x is equal to 4. So now we plug in here, that's going to be equal to 1 minus x squared double prime is 4 minus x times 4x plus 4 times 1, which is 2x squared minus 1. Okay, so this expanding is going to be equal to 4 minus 4x squared minus 4x squared plus 8x squared minus 4. That's equal to 4 minus 8x squared plus 8x squared minus 4. So 4 minus 4 is 0, and this is 0. So this whole thing is equal to 0, and that checks out because 0 is equal to 0. So I have shown that T1, T0, T1, T2 are solutions to this differential equation. And it can be shown that any Chebyshev polynomial is a solution to this differential equation. So thank you very much. Don't forget to subscribe to my YouTube video. And just for a quick notice, Chebyshev polynomials are used to approximate continuous functions. So they do have a purpose. Thank you very much.